this in a compact form, right? We took u to be f of x, and we picked g prime dx to be dv. So that's what we did. And then what is du? Du would be f prime dx, which is right here. And then v is g, which is right here. So in terms of u and v, our integration by parts formula looks like integral of u dv is equal to uv minus the integral of v du. And you want to realize that, so that you don't forget, you have, I always write u dv duv, and so the right hand side is uv minus the integral of v du. Okay? So what I want to do is go over a few examples today, which are going to be very similar to the homework. Now, when I gave you the integration by parts formula, I gave you that formula for only antiderivatives of indefinite integral. What if you have a definite integral and you want to use the integration by parts? What's going to change? Well, without the limits of integration, integral of u dv is the same as what? uv minus the integral of v du. But if you have limits of integration, uv needs to be evaluated at b and a and then subtract. And then integral of v du, you have to integrate from a to b. That's the only difference. Okay? And I'm going to show you an example in a bit to see how that works. Okay? So let's look at an example. First, let's say I have the integral of x squared times sine x dx. Okay, so what should I pick for you? If the integrand is the product of a polynomial and the trig function, usually you want to pick u to be the polynomial. Okay, so I am going to make a table here. Okay, so here I am picking u to be x squared, and I am picking dv to be the remaining part of the integral of the integrand. So this is going to be sine x dx. So what is du? 2x dx. And what is v? Negative cosine x, right? So integration by parts tells me what? Integration by parts tells me that integral of x squared sine x would be what? uv. So that is what? U times v is what? Negative x squared cosine x, right? And then minus integral of what? v du, right? So what is v du? v du is 2x times negative cosine x dx. You agree with that? So notice I had the integral of x squared sine x. Now I have to integrate basically x times cosine x, right? So I did good. I at least reduced the exponent on x and made it simpler. But that should tell you that, well, I can do integration by parts one more time and make it even more simpler, right? So now you look at the second integral. You look at the second integral, you have to apply, you agree that you have to apply integration by parts one more time. What would you pick for? I'm not going to simplify anything. I'm just going to pick u and v. What would you pick for u here? You're going to pick u to be 2x. Notice that this 2x is the previous du, right? And then what would you pick for dv? Well, in fact, it's the previous v, right? Previous v dx. Okay? So what is now my new du? 2dx, and my new v is negative sine x, right? You agree with that? If I pick u to be 2x, du would be 2dx, and then dv would be negative cosine x dx, and v would be negative sine x. Everybody's okay with that? So now I could say what? This is equal to negative x squared cosine x. So this is this term here minus, now this integral will come within the brackets. This would be uv, so I multiply uv like this, which would be what? Negative 2x sine x, negative 2x sine x, because I have a negative in front of sine, and then minus the integral of v du. V du is basically negative 2 sine x, right? Let's see if you agree with that. Is everybody okay with what I wrote? You guys agree with me so far? All right. So then all I have to do is simplify a little bit, okay? So this would be negative x squared cosine x. Notice that I'm going to distribute the negative outside of the brackets. So I'm going to get plus 2x sine x, and the next sign would be what? I have a minus outside of the brackets. I have a minus in front of the integral. I have a minus inside the integral. So I have actually 3 minuses, right? So that would be a minus the integral of 2 sine x dx. Is that okay? Yeah.
Where is the negative coming from that doesn't come to 2x?
You're talking about this?
Yeah.
This one came from, you're multiplying 2x and negative sine x. So negative 2x sine x. Okay, so the last step. Okay, this would be 2 times. What's the integral of sine? Negative cosine x. And I'll put a c at the end. Everybody's okay? You need to simplify a little bit more. That should be a plus 2 cosine x, right? So that's it. Is it okay with that? All right. If you're done writing it down, let me start a new problem. Suppose that I have the integral of x times sine 3x. How would you do this problem? I don't have sine x, I have sine 3x. You could do u substitution, you could pick u to be 3x. What's going to happen if you do that? The integrand will become, there will be some constant factors, but the integrand will be essentially u sine u. Right? And then you can do integration by parts. If you are doing integration, if you are doing a substitution first and then integration by parts, because if you want to use u and dv's for integration by parts, maybe you shouldn't use u for the substitution. Maybe use the w or z or something else. But in this case, you don't really need a substitution. You can just apply integration by parts. All you have to remember is that for integration by parts, you're going to use u to be x, and then you're going to use dv to be sine 3x dx. And so what is du? Du would be just dx. And v, what's the integral of sine 3x? What's the integral of sine 3x? 1/3 cosine 3x. That's what you have to remember, okay? Yes, negative. That's what you have to remember, that the integral of cosine 3x would be, sine 3x would be negative 1/3 sine 3x, okay? And then you just apply integration by parts. Once you see the new integral will be basically integral of cosine 3x. What's the integral of cosine 3x? 1/3 sine 3x, right? So what I'm saying, once I apply integration by parts, I am going to end up, well, let's do it. So what is that? This would be uv. So that's going to be negative 1/3 x cosine 3x minus the integral of v du, which would be negative 1/3 cosine 3x dx, because du is just dx, which would be negative 1/3 x cosine 3x plus 1/3 the integral of cosine 3x dx. And the last line would be what? Plus 1/3 times what? 1/3 sine 3x. So 1/3 sine 3x, that's the integral of cosine 3x. And so you have to write it as 1/9. Is that making sense? It is equally valid if you apply a substitution by replacing 3x by w or something. Then the integrand will become w sine of w. Okay. All right. So this is it. Any questions on that? All right. Another problem in your homework is similar to this one. Sine root x dx, and I'm going to put a half here. Okay. As it is, it doesn't look like you can apply integration by parts. Okay, but you know, when you have an integral, you don't know exactly what to do. You play around with it. So you try to do a substitution, you try to do integration by parts, or maybe both of them can be applied one by one. So in this case, we need to do a substitution first. So because I'm going to reserve u and v's for integration by parts, I am going to replace root of x. I mean, if you're going to do a substitution here, the only thing that makes sense to do is replace root x by something, right? And I can replace root x by what? Let's say let's use z. Let's use z for root x. And then what would be dz? 1 over 2 root x times dx. Now, could I say that then dz is 1 over 2? What is root x? Root x is actually z, right? So I'm going to put that z there. And then notice that 2z dz is dx. This is a little bit strange. I mean, not strange. I mean, you haven't done something like this before. Okay? You agree with that? Now let's do the substitution. I have the integral of half sine root x would be z, and dx would be what? 2z dz. And the reason I put that half there intentionally so that my expression looks nice. So this would be what? Sine z times sine z dz. Z sine z, that's the same as what? X sine x, right? X sine x. Right? X sine x. So basically we know how to deal with this by using integration by parts. Okay, now we apply integration by parts. What should I pick for you? The polynomial part, z, and dv would be the trig part, which is sine z dz. And so du would be dz, and v would be negative cosine z. Alright, so we apply that. What is that? You multiply u and v, I get negative z cosine z minus the integral of v du, right? V du, so that's going to be negative cosine z dz, which means I have negative z cosine z plus the integral of cosine z, which is negative z cosine z plus what? Sine z. And am I done yet? I have to replace z with what was z? Root x, right? Negative root x cosine root x plus sine root x plus c. You guys are okay with that? In your homework, you will see you have a problem where you have some number multiplied with cosine of root x, and you do the exactly same thing. Is that okay? Any questions at all? All right. Yeah. Yeah.
How do you just put the z or the 1/2 or the 3z?
Okay. So remember, we took z to be root x, right? Z and root x are equal. So I take dz. Dz is 1 over 2 root x dx, right? You agree with that? Now 1 over 2 root x. So you see the root x here. That's the same as z, right? So that's how I'm putting a z here. So this is 1 over 2z dx. So all I get is root x is replaced with z because z is root x. Once I have that, then I am multiplying both sides by 2z. Then I get 2z dz is dx.
Right? When you do that, usually though, don't you already have to have that when you
No, this is fine. You don't have to have. What you're saying is that do I have to have root x in my integrand, right? No, you don't have to have. The reason you had to have root x before, suppose that I am doing the same problem in Calc 1. All I know is to use u substitution. Am I going to be able to do it? No, because if I do this, I'm going to end up with z sine z, and then I don't know what to do. So that's why in Calc 1, we say that, well, if you don't have that, you cannot carry out this. But right now, if I put that z sine z, I can deal with that. Okay. Now, this problem will not work out. Instead of root x, if I have something else, say x squared. If I have x squared instead of root x, whatever we did for this problem, it's not going to work out. Does that make sense? I cannot find the integral of sine of x squared the way we did this. In fact, you cannot find a closed form integral of sine of x squared. You know what I mean by closed form? What I mean is that I cannot write the integral of sine of x squared exists. There is a antiderivative, but I cannot write that antiderivative in terms of familiar functions. Is that making sense? Is everybody okay? So what I'm saying is that, so I had sine of root x. So what if I have the integral of sine of x squared? Can I do the same trick? The answer is no. I cannot do the same trick. Okay? And you can try to do that. You'll see that you cannot do it, because the derivative of the derivative of x squared is just x, not in terms of x squared. And what's an antiderivative? If I write down this function, let's say s of x is the integral from 0 to x of sine of t squared dt, right? Is s of x an antiderivative of sine of x squared? By fundamental theorem, what is the derivative of s? It's sine of x squared, right? So you see what I mean? That there is an antiderivative, but can I write this antiderivative as in terms of usual functions? No, I can't. That's what I'm saying. But you don't have to know that. I'm just trying to make a point that this problem that we did, it works out because of this specialty with root x. Okay, it's not going to work out if I have x squared or some other powers of x. Okay, so that's that. Let's look at another example. Let's say I have the root pi over 2 up to root pi, and the function that I have, let's say, is alpha squared times sine alpha b alpha. Oh, actually, sorry. Let me delete that. What I want to write is alpha cubed sine of alpha squared. That's what I want to write. So you have a homework problem which is very similar to, except that the homework problem is in terms of cosine, not sine. And there might be some factors like 7 or 8 floating around in the integral. But essentially you'll be following the same steps that I'm going to do now. When you look at this problem again, right away you might not be able to see what to do, okay? So again, you have to play around a little bit with substitution and integration by parts. At some point you might after giving a lot of thought, you might say, well, let's try the substitution by replacing alpha squared by x. Let's try that. So what is dx? 2 alpha d alpha, right? So what is dx? If you think that in math you always have to start with you should always be able to start with the right path to choose. Well, if you do math for a long time, you know that it doesn't happen. So whenever you have some problem, there is a moment of struggle with it, and at some point you come up with the correct steps. Okay? Yeah. 2 alpha d alpha, right? And then
So can we rewrite it as, like, are you supposed to replace alpha with
oh, what am I doing? Sorry. Okay, so I got carried away here. So x is alpha squared and dx is 2 alpha d alpha, right? So I want to make the substitution now. And so before I make the substitution, let me rewrite my integrand. So I get pi over 2 and root pi. And notice that if I want to write d alpha in terms of dx, I need a factor of 2 alpha, right? You see that? In order to, let me write this way: half dx would be alpha d alpha, right? So to go from d alpha to dx, I need a factor of alpha. So you see, I have alpha cubed. I'm going to save a factor of alpha with d alpha, and then the remaining is alpha squared sine of alpha squared, right? I haven't done anything. All I did is rewrote. And now I'm going to say, that this is equal to, what is alpha squared? Alpha squared is x. So I get x times sine x. And then alpha d alpha is what? Half dx. Okay, now this is a what? This is a definite integral. If I am doing a substitution, I have to change the limits of integration. Now, when alpha is root pi over 2, what is x? X is the square of alpha, right? So what is x? When alpha is root of pi over 2, what is x? Yeah, it's just pi over 2. It's the square of that, right? And when alpha is the root of pi, x would be just pi. Right? Everybody's okay with that? Remember, we picked x to be alpha squared. So if I take alpha to be root of pi, if alpha is root of pi, then x would be pi. Right? Alright, so now I have, now the integrand looks familiar. It is half integral from pi over 2 to pi, x sine x. And what should I do? Integration by parts, right? So I take u to be x. What should I pick for dv? Sine x dx. We have done this before. So what is du? dx and v negative cosine x, right? And so integration by parts tells me I can rewrite my integral as what? I have a half, and how should I write the integral? You know what? Let me use a parenthesis here. What's the integration by parts formula? Well, this is uv. What is uv? Negative x cosine x. That's uv part, right? But uv, because I have definite integral, uv needs to be evaluated at pi and pi over 2 and subtracted, okay? Minus the integral of v du. So now v du. What is v du? Negative cosine x dx. And that integral should go from pi over 2 to pi. Are we okay with that? You guys are okay with that? Alright, so what do I have then? I have half. Okay, and Let me maybe keep it for now. Negative x cosine x pi over 2. This would be a plus, right? What's the antiderivative of cosine? Antiderivative of cosine would be a sine. I hope you don't mind that I am skipping a step here. So first of all, I write the integral as plus the integral of cosine x, right? And then the integral of cosine x is sine x. So I have that. And now what? Well, I plug in, right? Plug in, so this would be half. All right, so when you plug in pi within the first brackets, right, what do I get? Negative pi cosine pi. That's what I get when I plug in pi. Minus, I now need to plug in pi over 2. So minus pi over 2 cosine pi over 2. That's what I get. You agree? You have to be careful with the negatives here. Plus, within the second brackets, I plug in pi, I get sine of pi minus sine pi over 2. And I forgot, did I have the half? Yeah, half was all the way through like this. Right? Okay, now you need to know trig values. What is can you tell me what this quantity is? 0, right? Cosine pi over 2 is 0. What is this quantity? Cosine pi is negative 1. So I have a negative pi there, so this would be a pi. Alright, what is sine of pi? 0. What is sine pi over 2? 1. So what do I have? I have half times pi minus or plus? Minus 1 or plus 1? Minus 1, right? I have a minus here, so minus 1. Here's the plus 1. So half pi minus 1, right? That's the final answer. Okay. Again, the homework problem in WebAssign is exactly the same, except that instead of having alpha cubed sine alpha squared, it is alpha cubed cosine alpha squared. You should do the exact same steps. All right. I hope that with this exercises, it will be easy for you to do the homework. Okay. Any questions on integration? So I'm going to stop talking about integration by parts and move on to other topics. Any questions at all? Any questions at all? The next topic that we will be discussing is what we call improper integrals. Improper integrals. And we will be talking about improper integrals not just because some weird guy some time ago came up with this for fun. No, there are some practical applications on this. Remember how we defined the integral, right? How did we define the integral? Well, if we said that if I have a function f of x, and let's say the function f of x, and we consider the function f of x on some interval from a to b. So this is a closed bounded interval. It's a finite interval, right? Closed bounded interval. And we defined the integral of f. We defined the integral of f dx from a to b as what? As the limit of as the limit of the Riemann sum, right? I going from 1 up to n, f of wi times delta xi, and so we take the limit of the Riemann sum as the lengths of the subintervals go to 0, right? In other words, as the number of partition points goes to infinity. That's the definition of the definite integral. And remember what I said, if this limit exists, then we say that f is integrable on AB. If this limit does not exist, then f is not integrable on AB. And at the beginning of this semester, I gave you a result which says f is integrable from a to b. If f is integrable from a to b, then f must be a bounded function. What's the meaning of bounded function? It means that the value of f is always between two numbers, right? Two given numbers. So remember what we said, that if integral from a to b f of x dx exists, implies f is bounded. Bounded, I should say, on AB. On AB. All right. Now, what is an improper integral? There are a couple of different types of improper integrals. The first one that I want to look at is here we are talking about the integral over an interval, right? An interval where the interval is finite interval, closed bounded interval. What if the interval is not finite? What if the interval is it's an interval from, let's say, from 1 to infinity? That is the kinds of so let me give you an example of a improper integral. Let's say I have the integral from 1 to infinity of 1 over x squared dx, right? So here we are not integrating over a finite interval, right? We are integrating over an infinite interval. So this is an improper integral. So how should I define this integral? I mean, I have to give you a definition for these types of integrals, okay? So that's what I want to do. Is everybody clear? You guys are clear on what we are trying to do, okay? So let's say number one. Let's say that I have a function f. So consider a function f of x on an interval from a to infinity. So a is a constant here, a is a number. And we are going to suppose that the integral from a to t of f of x dx exists for every t larger or equal to a. Make sense? If t is a number bigger than a, then integral from a to t, we know what's the definition, right? It's the limit of the Riemann sum over that finite interval. And suppose that for any t, the integral exists, right? In that case, I can say that in that case we define the integral from a to infinity of f of x dx. What should be the definition of that integral? Can you guess? it should be in terms of the integral from a to t f of x dx. What should I do? What can you guess what should be the definition of this infinite integral? Anybody? Well, you take the limit as what? T goes to infinity, right? So you look at the integral from a to t, you compute the integral from a to t for any t, and then once you compute that, you take the limit as t goes to infinity. And if you do that, you get the integral from a to infinity of f of t dt, okay? Or f of x dx. Am I clear? So this is the definition of this integral. This is an example of a improper integral. There are others that I'm going to go over later, but this is one example of an improper integral, and that's the definition of this improper integral. Now, I said, well, this is not something that we are just doing for the sake of doing it. There are some applications. For example, let's see what's going on here. Let me say I have. Let's say I have, this is the x-axis, and let's say this is the y-axis, and let's say the graph of f looks like this, okay? So what's happening is that the graph is going like this, okay? And let's say this is the point where I have a, okay? Now, can someone tell me what is the integral from a to t gives you? If I take any t here, integral from a to t tells you what? This is the graph of f of x. Integral from a to t tells you area under the curve above the interval from a to t, right? That area is given by, that area is exactly the integral, let me use another color. This is exactly the integral from a to t of f of x dx, right? A to t, integral from a to t gives you the area from a to t, right? Now what's happening as t goes to infinity? As t goes to infinity, the curve, so the way I drew it, the curve is reaching the x-axis, but it doesn't touch the x-axis, okay? As t goes to infinity, then what's happening to the integral? Well, so what I'm asking is, what is the value of the integral from a to infinity? What is it trying to compute? It is trying to compute the area below the graph of f, above the interval from a to infinity, right? So that infinite region, right, that infinite region that I have, the area of that infinite region is given by that improper integral. Am I clear? And for some functions, this infinite region will have finite area, but for some other functions, this infinite region will have infinite area. That is, it doesn't have a finite area. Am I making sense? So there are infinite regions having finite area. There are infinite regions having infinite area. Am I making sense? So let me just stop there, because I don't have enough time to go over some examples. But next time we will go over examples like this.